All right, so in 11.3, we want to do number 44, which is about a box. This is a totally classic calculus problem.
All right.
Unfortunately, we're in pre-calculus class, so we're going to kind of hack at this thing a little bit instead of doing the elegant way, but it's okay. So they tell me that I have an open-top box is to be constructed from a 6-inch by 8-inch rectangular sheet of tin by cutting out squares of equal size at the corners.
All right.
Which means that I have 8 this way, 6 this way, and I'm going to cut out squares at the corners.
Yeah.
Okay, there's a square at the corner. That's getting cut out. What am I doing with that?
It's going to be one side of the box.
Yeah, it's going to be one side of the cube. You're about to getting that 6 times.
Yeah, you're throwing that away.
Oh.
Right, this part going in the waste bin. And then you're cutting the same size square out of this corner, also waste bin.
Oh, I get it. You're gonna fold
Same
it.
size square here, also waste bin. Same size square here, also waste bin. Right?
Yeah.
Flip, gone. Then, along this line here, you're going to fold that up, right? Fold that one up. Along this side here, you're going to fold that one up. This side here, you're going to fold that one up. And here, you're going to fold this one up. Right? So what you're going to make in the end is a kind of, in my picture, shallow little box, right?
Very nice. Beautiful.
Mine looks kind of squarer than it should have. Dimensions are hard. So, if I cut out some sides, what were the lengths of the sides I cut out? What did they say in the problem? They said column X.
Yeah.
Okay, that's kind of boring. So each little square is X by X, right?
Yep. Seems about right.
Okay, so then what's this distance left over after I cut those out?
8 minus 2. Yeah.
Okay, it was 8, and then you took away twice the side of the square, right? And then vertically here, on the other side, well, sorry, I say vertically. I mean vertically, like up and down wise on the board.
6 minus 2x.
That's going to be 6 minus 2x. Okay, so those are going to come over to my little box picture, right? So I got an 8 minus 2x on this side, and a 6 minus 2x on that side. And then how tall is your little box?
X.
Oh, yeah, cool. Guys all down with this?
Totally down.
Okay. So then they're saying, find the formula for the volume of the box as a function of x.
Yeah.
Okay, that seems like it's probably pretty easy.
Yeah.
Volume as a function of x, right?
Mm-hmm.
So, how do you find the volume of the box?
Just multiply them together.
Multiply all the what?
Terms
times
dimensions.
width times height.
Yeah, multiply the length times the width times the height. So I think I got x times 6 minus 2x times 8 minus 2x.
Seems like a cube problem.
That's all with me on that? Okay, cool. And then, for what values of x does the formula from part A make sense in the context of the problem? In other words, what's the domain of that function in kind of real terms?
Oh.
From
6 or 8.
yeah,
Like, what's the smallest x you could cut out?
definitely not 0.
Up to 6. You just can't do 6.
You can't do 3.
Okay,
You can't
so
do that.
why can't you do 3?
Because then you would eliminate like both sides
Yeah,
of the
just
6.
cut out
Because
the
it would
entire
be
thing.
6.
So you'd have a box like this, right?
Mhm.
And you'd cut out this chunk,
Oh, right, exactly.
right? You'd cut these out and throw them away.
Yep.
And then
Hold up nothing.
hold up nothing.
You don't have a box.
Okay, so I get 0 volume out of that. If I tried to cut out more than that, these would overlap, right?
You get a
Yeah.
birthday card.
And I have no idea how that would work. Like, tin snips don't do overlapping well. Like, once I've cut something out, I can't cut through it again. It's gone. So, at the very least, my x's at worst could be 3. And it could actually be 3, right? You could actually do this. It would be dumb, but you could do it. Okay, so what's the smallest they could be?
Any reasonable number before, after 0, rather than 0.
Does it actually have to be bigger than 0?
No, it can be 0.
I think it could actually be 0, right?
Hey,
You just
leave it.
don't, like,
Yeah.
get your piece of tin. That one's easy, right? You don't
Yeah.
even need the tin snips. You're just like, yeah, I'm just gonna make a box.
Yeah.
Here's your box.
Do nothing.
Don't put much in it. Okay, so I think my x's live between 0 and 3. Maybe inclusive. You might say to yourself, well, neither of those things is really a box.
Yeah.
So you could maybe argue that these shouldn't have the equal signs on them.
Okay.
I'd probably put the equal signs on them just cause. Like, just because I feel like that's the dumbest case, and I'd like to highlight that exists.
Nice.
Let's see. And then sketch a graph of the volume function. Okay, so for this, I'm going to disregard that thing I just learned about the domain. I'm going to sketch the function, and then I'll restrict it.
Okay.
You guys see that? So what kind of thing is this guy?
It's a cubic one.
Yeah.
It's a cubic. And it's going to have, what's the leading coefficient?
X to the
There's an x to the third. What's the number?
6. The 4.
Where do you get the x cubed?
From X times 2.
It looks like it's 4.
From multiplying all the x things
Four.
together, right? So that'd be x times 2x, really x times minus 2x times minus 2x,
So 4.
Yeah.
which would be 4x cubed, which is specifically positive, right?
Yeah.
So this is going to look like a cubic with positive exponent, or positive coefficient. Right? So it's going to go down on the left, up on the right.
Okay.
Is all good with that?
Mm-hmm.
Okay. Where is such a function 0?
3.
Okay, we just found 2 of them, right? It's 0 when you don't cut anything out.
Yeah.
It's 0 when you cut
And at
3 out. And then just eyeballing this thing, where else is it 0?
4.
Yeah, when you cut 4 out. 4 doesn't make any sense physically, right? But at the very least, I can put that dot on my picture.
When you cut 4 out, then you just cut out the whole thing.
Yeah, there's like cutting out of anti-things and throwing all of it away anyway, and yeah, it's a little bit bizarre. But my picture should say, okay, if I'm going to go up over here, and it has a single 0 at 4, that means I'm going to go through 4. Then it has a single 0 at 3, so I'm going to go back up through 3. And then it has a single 0 at 0, so I'm going through 0. So I think I get a picture that looks more or less like this.
Yeah. Yep.
And I don't really know the heights there.
Yeah, it could be more
Could see
vertically
that?
stretched
Like-
or not.
It's finding them calculus.
The area. underneath
Yeah.
it.
Finding them is kind of a calculus thing. I could probably guess, right, that's the bottom of this is like halfway between 3 and 4, give or take. If I look at this for a second, I could probably think, well, it's probably bent a little bit to the left there, right? This is probably just a little bit closer to the,
But why? Why?
'cause that's how I feel like functions happen. There's not really a great reason.
Okay.
Like, we could prove with calculus that it's to one side or the other, but from this viewpoint, I'd just say, there's probably bent a little bit this way because this thing's a bigger lever.
Okay. Actually, no, I can understand. There is a logic there, and I've heard it explained.
Yeah. But it might, I guess it could be the other way. Like, I don't know. It's someplace in there. It's probably around 3.5.
Yeah. Okay.
Right?
Fair
Like,
enough.
give or take. It's 3.5. So, if I wanted to find out exactly where it was, I'd probably need a little bit of calculus. On this guy, to find out where this one is, I'd probably need a little bit of calculus, but I could guess that it's about 1.5. Let's see that. So they're asking for me in D, what approximately is the maximum volume of the box? Okay, so that's restricting the domain to things that make boxes, right?
So possibly.
So that stuff doesn't make boxes, and neither does any of this. Right? None of that makes boxes. To make boxes, you're in between 0 and 3. So we could restrict that domain just by like erasing the rest of the function. So, like, right?
Yeah.
And then if I wanted to know where the maximum is, I guess it's at about 1.5.
Mm-hmm.
And then to find the volume that goes with 1.5,
Plug it into the thing.
yeah, plug it into the function. So I'd say the volume is about, oh, sorry. That was part B. Part C was draw the picture. Part D is the max volume is about V done to 3/2.
Yeah.
If I wanted a better answer, what could I do?
Plug it into your graphing calculator.
Yeah, don't settle for this picture, right? Get yourself a graphing calculator, and then under the calculate area, there's a maximum. So you could calculate that maximum using your graphing calculator. Do you guys want to see how to do that? Do you guys trust you can do that? Yeah, you want to see? Okay. All right. Oh, where'd our function go? So
Erased it.
I was trying to grab v of x is x times 6 minus 2x times 8 minus 2x, and find the maximum between 0 and 3, right? So first things first, you need to get a graph of v of x is x minus 6x, that thing. So you go into y equals, right? Delete the function that's in here, because there's always going to be something left over. And then put that guy in. So I need x, and then parentheses, and a 6 minus 2x, and a parentheses, and an 8 minus 2x. And then I need to hit graph. Give me a picture. Okay, cool. And then if you go into window, you only actually care about x's between 0 and 3, right? Because those were the ones that made sense for your picture. So you go to 0 to 3, and then try it again. Whoopsie daisies. Okay, thing's too high, right?
We only care about the stuff above the.
Yeah, and I really only care about the stuff above that x-axis. So I go into window again and go, okay, so I only care about from 0 up to,
You can go up to 30.
I don't know, guess something. Hey, look, that's a pretty good looking picture. Oh, cool, it's skewed off to the left. I was wrong about the other one. The other one's skewed off to the right. So, if I want to know where the maximum is, I could do this kind of like dum-dum thing where I'm just like scrolling around with the cursor, right? But that's lame. A better solution would be to hit the trace button at least, right? And then you could follow this along. And you just look at the y's and see when they start going down. Looks like 24.25 is the best I'm getting out of the trace. But better yet, there's a calculate button. So if you hit second, and then above trace is this calculate. You look down here a ways, there's a values, 0, minimum, maximum. I wanted a maximum, right? So I should go scroll down to the maximum part, hit maximum. Then it's asking for a left bound. So what was the leftmost end of this thing that I was interested in?
0.
0. Or you can just, so you can either type 0 or you can just scroll the cursor to left of the top.
Yeah.
And then it wants a right bound, so you need to scroll to the right. Okay, so now I'm clearly below the top, so I hit enter. And then it's asking for a guess. And it doesn't really actually matter so much where you guess. I would guess relatively close. Like just bring the cursor into the middle a little bit. It doesn't really matter too much. If there's 2 maximums, it can do weird stuff. Cool. Maximum happens at x is 1.13 and y is 2.25. What does that mean? X is 1.13 and, wow, x is approximately, and y is approximately 24.25. Okay, so my original guess about
Would be a better approximation.
okay, fine. We could round the right way instead of just truncating. So, what does that actually mean in terms of our little box?
It means the maximum volume we can attain by cutting out the corners is 24.26, approximately 24.26.
Okay, so the biggest
The units on that.
box you can make, that's a good question, Zach, is about 24.26. What are the units on that?
Nothing as of now.
Something cubed.
It's got units, and there's something cubed. What were the lengths in at the beginning of this problem?
I think inches.
They were in
Yeah.
inches,
We
and I was
never
cutting off,
times it, no.
so it was an 8-inch by 6-inch piece of tin,
Oh, okay.
and I was cutting out X inches from each corner,
Right.
right? So it's going to be in inches cubed.
Okay, yeah.
Since the units on 8 minus 2x will be inches, the units on 6 minus 2x will be inches, and the units on x itself will also be inches. Let's cool with that?
Yeah.
So I'd say the biggest box you can make is about 24.26 inches cubed
By cutting a 1.13 inch.
by cutting 1.13 inch,
Indentations.
maybe about,
Yeah.
a good idea, about 1.13 inch squares from each corner. Okay, then further life question. Where do you find 1.13 inches on a ruler?
Well, you can divide between the 2 inches.
Because there's a thing, right, between math and rulers. Like there's a little bit of a disconnect between math and carpentry. In math class, I use decimal points, and in carpentry, they use
Fractions.
fractions of inches, right?
I multiply the decimal by 32 to get a pretty good approximation from there to 16ths. Because you can get like, a little more precise.
Yeah, so basically you want to convert to fractions, right? And the way I'd do that is I'd probably look at 1.13 inches, and I'd think, well, that's like 1.125 inches, give or take. And that's an inch and an eighth.
Yeah.
You guys
But
follow that?
if you were making cuts, you'd want to be an 8 plus, really.
Yeah, and then you'd want to put your cut into the square you're removing, right?
Yeah.
Not into the material.
Yeah.
Does that make sense?
Yeah.
But that's when you're working with like wood, when you
Yeah,
cut
when
wood,
you're
the
using
wood you cut
tin
with a saw.
snips,
yeah,
right?
tin snips, you won't lose any material.
You won't lose anything. So you cut
I thought
along
this wasn't
the
a
line.
woodshop class.
Turns out sometimes it is woodshop class.
Yeah, I'm glad that
You guys,
We have way more fun.
you guys good with this? Question 6?